Hi and welcome to this in our first video on integration from the Year 2 content section. So we're cracking into integration, so you need to be comfortable with the Year 1 integration content, and you need to make sure as well that you've gone through all the differentiation stuff and all the trig stuff as well, because it's all going to be mixed in and used within this. If you've got all that sorted, then let's get busy and have a look at what we're going to do. So this PowerPoint contains quite a lot of content. But in this first video, we're just going to look at that first point, which we've highlighted there, which is just looking at how we go about reversing chain rule. And we'll have a little look at reversing trig functions as well, because that's part of the same descriptor. So here we go. Let's start off with a bit of differentiating. Let's look at how we differentiate using chain rule by inspection, and then we'll simply come up with a method for integrating by reversing it. So here we go. So if we're going to differentiate 2x plus 3 all to the power 4, what I've got to do is differentiate the function in the bracket, so that's the 2x plus 3, and so that comes out to the front, there it is. We've then got to bring the power to the front, that's the 4. We've then got our original function, still saying the same, and taking 1 off the power. And so there we go, there's our differentiated version. And to integrate, all we've got to do is just reverse those steps. So what I'm going to do is integrate 8 bracket 2x plus 3 cubed, and show that we're going to get back clearly to this thing here, 2x plus 3 to the power 4. So here we go. Let's just reverse all those steps. So we're going to start off with the green bit. So we've got to add 1 to the power. So here we've got our original bracket. We've now got 1 added on to the power. The function in the bracket is going to stay the same. Now we've got to do the opposite of bring the power to the front, which is dividing it. And again, we know with integration, it's dividing by the new power. Generally speaking, what most people tend to do is rather than write it as a divide, we write it as multiplying by a fraction, because it just keeps things a little bit neater. So that's the divide by the new power bit, so that's essentially divide by 4. And the last bit, as you probably guessed by now, is going to be to reverse that thing there. So we've got to do a divide by 2, in this case times by half. So what's happened there is now you can see we've got those bits cancel out, and then we're left with the 2x plus 3 to the power 4. Now, what that means in general terms is if we're going to integrate something of the form ax plus b to the power n, all I've got to do is that bit there is the reverse and the multiplying, that bit is the divide by the new power, and there it is, the original function raised to the new power. So, let's have a look at this in the context of an example. So we've got an area under the curve, and we've got the curve y equals 1/3 4x plus 3 to the power 5 plus 1. And we've got to integrate it between 2 limits, so off we go. There it is. Let's do the integrating. So that third, that's a constant, that's just going to sit there, that's going to remain unaffected, so I've just kind of left that there. We've now got the dividing by the differential of the function, so that's divided by 4. Here's the divide by the new power, because we're raising 1 to the power, was power 5, it's now power 6, so that's the divide by the new power. There's my original function, there's the new power, and then finally that plus x is the integrating the 1. And we've got to do that between limits. So the key thing I'm looking at is this one here. So we've got that, let's go again, that original third, dividing by the differential from the bracket, dividing by the new power, original function to the power, add 1 to the power, and there it is. So we end up with that, and then we're just going to proceed as per normal. So let's just put in the limits and subtract, and there you go. There's the area under the curve between those 2 limits. Okay, so on we go. So what we're going to do now is have a look at some other results that come from chain rule, and what we're going to do is just have a look at what happens when we differentiate, and then just use the logic of that to figure out what's going to happen if we have to integrate. So if we're differentiating a sine function, sine ax, we know we get a cos ax. So we've got this multiplier of a. So to reverse that, so what I'm going to do is integrate cos. So I've got 1 over a, so I'm dividing by the a, and the sine ax is there. And there's my constant of integration. So when I'm integrating trig functions, instead of multiplying, essentially, it's dividing by the x coefficient. Same principle with cos. If I differentiate cos, I get sine, but it's minus sine. So now if I'm integrating sine, I'm going to get minus cos. And again, that's something you're going to have to make sure you got your head around, which way around it works with the positive and negative signs of your trig functions, sine and cos. Exponential function, again, what we're doing is keeping the power the same, and we've got this a at the front, so we're going to have to reverse that by doing a divide by a. So that becomes 1 over a e to the ax. And then finally, log function, if I differentiate a ln function, ln ax plus b, I get the fraction a over ax plus b. So therefore, if I integrate a over axb, I just get back to the ln function. Now, with this one particularly, useful result, but we've got to have this in a particular form, and we'll look a little bit more later on in future videos of how we can kind of manipulate the original expression to get it into the form that we want. But essentially, what we're doing, particularly with the first three, is just reversing differentiation, essentially just doing a divide. And again, watch out for the signs on these two. In addition to that, you've got all your other trig functions, and all of those are given in the formula booklets. So you can look at the formula booklet, and some of them you can find by looking at what you get to differentiate and realising just reversing it. Some of them are specifically mentioned as integrals. Those are your standard results. You'll notice cosec and sec have got two different versions of the same thing because we've got additions inside the ln in both cases. But generally speaking, you won't be using these ones too much, but you will get to recognise and use these ones here. Okay, and there we go. So it'd be a good idea now to spend some time doing plenty of practice on those basic examples, just so you make sure you've got the basic principles in your head, because when we move on, life's going to get a whole lot more complicated. Alright, cool.